In this problem, we are told to predict the relative magnitude of Kc and calculate Kc. First off, let's start with finding the concentration of HI gas. We are told how many moles of HI gas we have, which would be 0.2 moles of HI gas. And we are also given the volume, which is 2.0 liters. This would give us an overall concentration equal to 0.100 molar HI. Now, we are told to compare our initial concentration with the equilibrium concentration being equilibrium is equal to 0.078, which is smaller than our initial 0.1 molar. So we can expect that Kc is less than 1, meaning that our reaction must proceed to the right to achieve equilibrium. But now, how do we find our equilibrium values? We do this by constructing a reaction table, or also known as an ICE table. Let's start off by defining our QC, which in this case would be equal to the concentration of H2 times the concentration of I2 all over the concentration of HI raised to its molar coefficient of 2. And that is given here in our balanced equation. So now we go ahead and construct our ICE table. I for initial, C for the change, and E for our equilibrium value. Now remember, our chemical reaction is as follows. 2HI gas reacts to create H2 gas plus I2 gas. Initially, we have 0.1 molar, but we can leave that out since we know our ICE tables in terms of molar concentration. So we start off with 0.1 molar HI gas, but we have 0 H2 gas and I2 gas. So our change would now be negative 2x. It's negative 2 because we're losing 2 moles to create 1 mole of H2 and I2 gas. And as stated in the previous slides, we use our reaction table to sum up what we have so far, being 0.100 minus 2x And then right here would be 0 plus x, which is x, and same over here. Now, remember that we are given our equilibrium value for HI gas being 0.078 molar. Now to solve for x, we set both of these equations equal to each other. This would give us and then performing some algebra, we get that x is equal to 0.011. So now we can find our equilibrium values for H2 and I2 gas now that we know that our x is equal to 0.011 molar. Initially, we are given the equilibrium value for HI, which is equal to 0.078 molar. Equilibrium value for H2 is equal to our x, which is also equal to 0.011 molar. And the same with I2 gas. Now that we have our equilibrium values, we can plug it in to our QC, which would now turn into our Kc since these are values at equilibrium. So Kc would now be equal to concentration of H2 gas times the concentration of I2 gas all over the concentration of HI gas raised to the power of 2. This would give us 0.011 times 0.011 all over 0.078 raised to the power of 2, giving us our Kc as 0.02. And that is how we use a reaction table to find our value of QC and our equilibrium values.